All right, so question number 8 on the review is you have an $18 tip on an $80 meal, and then you're going to have another meal that's, say, $50, and you want to figure out the tip. And so you could do a proportion because you want to keep them proportional. So this tip over this meal should be the same as this tip on this meal. And you can cross multiply, which means that when you take 18 times 50, it's going to be the same answer as when you take 80 times t. So whatever 80 times t is, 18 times that is what? 900. Divide by 80. So your tip should be 11.25. Another idea might be to do a percent. So take $18 tip out of 80 total, multiply by 100, and be like, okay, well, I'm tipping 22.5% on that meal, so then I should use that same percent on the other meal. That would work. And you could do a rate. So you could take $18 divided by $80. It's a little, I don't know, the units are the same, which makes it a little weird, but if you divide, you're going to get 0.225. So what that would be is about a little bit more than 22 cents of tip money for every $1 of meal money, and then you can multiply by the cost of the meal. So that's a little obscure on this one, but it does work. All right, let's flip to the next page. And again, try these on your own before watching the video. All right, I'm going to pause it here, and then so make sure you've done 9 through 11. All right, so let's look at this one. Number 9. I like to make my chart this way, weighted and then grade. And if you're going to weight something, that means you're going to multiply it. So if someone weighs twice as much of you, you'd multiply. You have a 4-credit class, 3 credit, and 5. You get an A, which you have to put it in number form because otherwise we can't do math. A B, which is a 3.0, and a C, which is a 2.0. And you're weighting these. Okay, so A's are worth more. Higher credit hours are worth more. And then lower credit hours and D's are worth less. Okay, so even though this is a 5-credit class, the fact that you got a C in it, you're actually getting more points from this 4-credit A than what you are on a 5-credit class because you did worse in it. Okay, so if you add these up, you get 35 what we call quality points or grade points. But you have to divide it because it's an average over all your classes. So 9 divided by what? 12 credits. And then that's a GPA is grade point average. So it's an average. And we usually do 2 decimal points on that one. So a 2.92. Make sure it's reasonable. I mean, they have an A, a B, and a C. So obviously this can't be a 3.92 because, you know, that's going to bring it down. So is that. So just make sure it's, you know, makes sense. All right. The next one is a weighted grade as well. So it's similar, but just a tad different. So make sure you try that. I'm going to pause, and then we'll go over number 10. All right, so again, we have a weighted grade. But this is a teacher that does weighted grades, which I do as well. 70% is the exams. 30% is everything else. All right. And so again, you are weighting it, making those tests are worth a lot more than the homework and other things. So, or quizzes in this case. So let's see, you have an average of 85% on your tests and a 90% on your quizzes. And so you're going to multiply across to figure out, you know, what your grade is, because you're going to get more of the test average counting towards your final grade than you are of the quizzes, just because they're heavier weighted. So when you multiply, you get, what, 59.5 and 27. And then add those up, you get an 86.5. Now again, you do have to divide by the total, but because I put these in decimal form, the total is 1. If you left that 70 and 30, these numbers are going to be bigger over here when you add, and then you divide by 100. But when you put these in decimal form, this adds up to 1, and so it doesn't really do much. So 86.5 would be your grade. All right, try all the exponent rules. I'm going to get a clean sheet of paper here, and then we'll go through these. Okay, so let's look at these first few ones. Right away, I see that this one has some adding in it, and so does this one. So those, like this one, especially up here, there's no multiplying at all. So exponents are not going to change. This is just cats and dogs collecting like terms. So I have 15 squares. Think of them. I could draw them all, but that's a lot. But I guess I could. So you have 15 squares, and then you have 25 squares. So you have 40, but they don't change shapes. They're squares. So you have 40x squared, or cats and cats make more cats. This one also, see how there's adding and subtracting there? But there's also multiply. So this is where you're either going to do the distributive property twice or the box. So x times x, exponents change when you multiply. 3x, negative 8x, and what? Negative 24. And then you can collect like terms here. So I have x squared, and there's no more of those. Here I have a negative 5x, so cats and dogs collecting like terms, and a negative 24. And I can't mush that more because these are not like terms. This is my final answer. The only things that are like terms are these two right there. So I'm done. But notice there's add and subtract in my answer, or in this case just subtract, because the original had that. This one had adding, but because everything added, like 2 cats and 6 cats, you just get 8 cats, so that's why it all added. But if I put something with it, like say plus, I don't know, like 8x or something, tack that on the end, then the answer would have that tacked on as well. Okay. Now, the rest of these have no add or subtract in them, so they are not collecting like terms. They are exponent rules, and the easiest way to do these is not to memorize, it is to write them out. So this means you have 2 sets or 2 groups of 15x cubed. And if you want to write that down even further, you can break this down even more. So x and x and x, x, x. So I get 225, and how many x's do I have? Let's see, it looks like I have 6 of them. Now, if you want to memorize a rule, numbers are normal, so 15 squared, that's going to be okay. But a power to a power, the little mnemonic is PM, like post meridian. So when it's a power to power, you multiply these. All right, let's look at the next one. Again, division, let's just write it out. 3, 4, 5, 6, 7, 8, 9, 10. So we're just writing them out as factors, which is what they mean. Like 3 to the 5th power means 3 times 3 times 3 times 3, 5 times. 6 to the 5th power would be 6 times 6 times 6, 5 times. And I'm not sure why I just did that, but just going to ignore that. Oh, that was not good. Okay, well, we will start over then, I guess. What did I have? 6 and x, x. How many of them? 5, 6, 7, 8, 9, 10. And then what? 3, 1, 2, 3, 4, 5. All right, so we're dividing. So those are going to cancel. 3 goes in there twice. Numbers are normal. And then cancel, cancel, because they're dividing. And 8 divided by 8 is 1. So like technically these are all a bunch of 1s. But when you multiply by 1, it doesn't do anything. So then I get x to the 5th. Now again, if you want to memorize tricks, which I don't recommend, but if that's your method, divide, and then remember Nintendo DS, when you divide, you subtract the exponent. So 10 minus 5 gives you the 5. But again, numbers are normal. All right, I'm going to pause, see if I can get back to where we were, or rewrite them anyway, and then we'll keep going. Okay, so let's look at these. Again, you're going to be able to mush these completely. Exponents are going to change. So what does this mean? There's no parentheses, so just that is cubed, and no parentheses, so there's like an invisible dot in between there, so x to the 4th would be that. Okay, and so numbers are normal, negative 35, and you're just counting x's, so I have 7 of them. Again, if you want to memorize a rule, numbers are normal, so like 7 and negative 5 are the same as always. But again, when you are multiplying exponents, you add them, so you can think of kind of ma. Right, so numbers are normal, and I added my exponents. All right, now, the next one has a couple steps to it. So first of all, before I square it, I want to simplify the inside. So numbers are normal. 2 goes in there 8 times. X divided by x is 1. Those are going to cancel. So right now I have 8. And then 5 of these y's will cancel. So I'll get y to the 5th. And then after I get an answer to that, then I'm going to square it, which means I have 2 sets or 2 groups of this. So I'm going to write it twice. And again, if you want to write it even more so to see what's going on, you can write it even further. All right, so numbers are normal. 8 times 8 is 64. I'm counting my y's, and I have 10 of them. again, if you want to memorize rules, division, right? Divide normal and then subtract exponent. So like 1 minus 1 would have been x to the 0 power. But we don't write it because anything to the 0 power is 1. So that's kind of a waste. So they just go away, subtract, and you get that. Again, a power to a power, exponents are normal, and then you would multiply if you want to memorize that rule. But again, if you just write it out, you'll get it. All right, I'm going to write those last few on the bottom here, so I'm going to pause to do that, and then we'll talk about those. Okay, so this one is saying order of op, exponents are first, so 8 times 8 is 64, and then just make it negative, okay? Because think about it, if you had 100 minus 8 squared, you would get the 64 first and subtract it from 100. So you don't know if there's like something in front of here or not. So again, only this is squared and you make it negative. This is a parenthesis saying it's all squared, including the negative. So it's saying you have 2 sets of that, which is a positive 64. Most of your calculators should do this. This one we're multiplying, which again is like volume, area, you're creating a new shape, exponent should change. Numbers are normal, negative 15. Count your x's. There's 1 over here, 3 over there. That makes 4, and y squared. And again, if it helps you to write it out, then write it all out at the kind of DNA level. So you can see the negative 15, you can see the 4 x's, and you can see your 2 y's. All right, down here, this is not multiplying. This is subtraction. So again, cats and dogs, exponents should not change. You're not creating new shapes. But you do, when you subtract, you have to add the opposite. You have to subtract all of this. So add, this guy's going to become negative, this guy's going to become negative, this guy's going to become positive. So you're distributing that negative through. All right, so x squared, 2 of them, minus 1, cats and dogs, I just have an x squared. We're collecting like terms. I have 2 squares, I owe a square, I have 1 square left. You can put the 1 if you feel like it. You have 3 x's, you owe 4 x's, so you still owe an x. Again, you don't need the 1, but if you want to put it there, it doesn't hurt. And you owe $9, you have $10, 1. So you could write your answer like that, or you could write it like that. And either one of those is going to be totally fine. All right, pause there, check the next page, make sure you have it done, and then we'll talk about it. Okay, so question number 12 is saying, what's going on here? And so this one just has an invisible dot there. So this is saying order of op, exponents are first before you multiply, right? There's no parentheses. So you do exponents, then you multiply and divide left to right, and then you'd add and subtract. So this one definitely has exponents. So I would have to do that first and then multiply by the 6. So that's what that one means. This one I have parentheses. So I would do that first and then do the exponent with it. So this means I have 3 sets of all of it. So 6x times 6x times 6x. So the answer to this one is 216. And again, numbers are normal. You could cube it. And a power to a power, if you want to memorize, is multiply, but you can see them right here. So this has an answer of this. This one, really, that is the answer. Okay, that's the most simplified it can be. All right, the next one. We have 2 legs, and we're trying to find this one. So Pythagorean theorem. If I could write. So in Pythagorean theorem, this one matters. The hypotenuse is across from your 90. It's the longest side, and I don't know it. So that's my variable. I know this one. 6 times 6 gives me an area of 36. 7 times 7 gives me an area of 49, and those are numbers, so I can add those up, and I get a total of 85. But that's the area right there, and I just want the side length. So to undo squaring, use square root, and so the length is about 9.2 feet. All right, the one down here, I give you the hypotenuse and a leg. So, but again, we still use Pythagorean theorem. It's a right triangle. But now I know C. So C has to be the longest side, opposite the right angle. So that's 12 times 12 gives you an area of 144. 8 times 8 gives you an area of 64. But I'm missing one of those legs. Now, I don't know how to add these. And again, you want variables on one side, numbers on the other. So to get rid of order of op backwards, you always add and subtract first. So now I get that the area of b squared is, what is that, 80? Okay, so if I subtract the big area and the other one, whatever area is left is going to be the area of that thing down there. To unsquare, use square root. So b is about, what, approximately 8.9, and I think that one was in inches. All right, we're going to stop there, and then I'll make one quick video on the last 3 questions.